Okay, in this example it says the internal energy of the gas in a gasoline engine cylinder decreases 284.1 joules if 61 joules is done by the gas. So you have a piston, and inside you have gas, and what you want to do is overall you're going to decrease the amount of energy that is in this system. Okay, so you can do that two ways. Either heat can flow out of the system, or work can be done by the system and causing it to expand. So it says overall, let's look at our given. The given information you have is overall the energy decreases, so that means it loses 284.1 joules. It says if 61 joules of work is done by the gas, the key there is the work is done by the gas. So in other words, the energy is going to be lost by the system. So you have a negative 61 joules. It says how much energy is transferred as heat. So you're trying to find what the Q value is. Now this right here is a principle of the law of conservation of energy. Energy has to be conserved. More specifically, we've been calling it the first law of thermodynamics because we're talking about heat and work. Now remember, it's no different than the law of conservation of energy. Okay, it's just called something different. Now the formula that's involved here is delta U equals Q plus W. So we look at our solution. Delta U, remember, is negative 284.1 joules. Remember, you're decreasing the energy of the system by negative 284. Q we don't know, and we know that we are going to lose 61 joules as a result. So we add 61 joules to both sides, and what we end up with as our solution is going to be 223.1 joules. Now that's going to be a negative number, and it should make sense to you guys that if you decrease the overall energy of a system by 284 and you're only losing 61 through work, you actually have to lose the rest, 223.1, you actually have to lose the rest through heat. So it turns out we didn't have any relevant information. We did match. We said we were looking for Q and we solved for Q, so that works.